Hello everyone, welcome back to my YouTube channel Data Speaks. In this video, we are going to talk about data structures, list, tuples, dictionary, and set. We'll be covering list mostly in this video, and in the next video in the series, we'll cover tuples, dictionaries, and sets individually. Let's straight dive into what is list type of data structure and why that is important in Python programming, specifically for data science use cases. In Python, we call list as a collection of data that is ordered and that is mutable, also allows duplicate values. You can store many same values in the list. It can also store multiple type of data in the same list. In one single list, you can store integers, you can store strings, you can store floats, or even other nested lists within one single list. We'll see all of those examples here one by one. As we said, that list is the ordered collection of data values, means that you can access the values in the list by index values or index numbers. This allows the values to be duplicate. We don't have to worry about duplicates being removed by itself in list. You can store multiple values in the list. We have seen in our previous videos that a list can store more than one values. That's what we'll be looking at in some of the examples of the list. Let's straight dive into the coding and let's start learning about list with some examples. To begin with, we need to know that lists are defined using square brackets. Square brackets. That means this type of two open square bracket and close square bracket. So lists are defined in this way. When I have open and close square bracket, open square bracket, close square bracket, and I have values inside them. Let's begin with a fruit name, apple. This, if you check the type of apple, this will give you list. But if you do not have square brackets within apple and you have checked the type of apple, it will give you a string. So to qualify a value to be a list, you must have opening and closing square brackets around the value. Not only apple. Let's put here 10 and let's check the type. That is still the list. If you put 10 without square brackets, here it's going to be integer. Whenever you have square brackets around one single value or more than one value, that makes that value still to be list. So this first condition to be list is satisfied when you add square bracket. This is how we initiate creating the list. So if you remove that type function from there, and let's give variable name here. Variable name we're giving is numbers, and inside that we are storing the values from 10 to 13. If you check the type of numbers, that's going to be list. So numbers is the list of numerical values. If I say some different values, apples, banana, oranges, grapes, I give this name. First of all, let's check what is the type of these values. It is the list. I want to now give a name to this list. I want to give fruits. Fruits here, and then run that. If you check the type of fruits, it's going to be the list. Whenever you have the values and you have the opening square bracket, closing square bracket, that will make the value to be list. Doesn't matter that is multiple values or just a single value, it will still be the list. Before proceeding further, let's understand what are the key properties of the list. So the first one is ordered. Lists are ordered by index level. It's not ordered like alphabetical order or larger to smaller order, etc. They are ordered by index position. First index position, second index position, third index position, etc. They are mutable. Once the list is defined, you can change the value at the index level. You can store duplicate values within a list. You can store multiple of same values without any issues. You can also store multiple values of different data types in the same list. You can also store multiple nested lists within a single list. So you can create lists inside the lists. And lastly, you can iterate over the values in the list at the index position or at the index values level. So you can extract one or multiple values at the index position by iterating over the values in the list. You can make updates on the values while iterating over the values of the list by index positions or by index values. Let's create some lists and let's learn with examples. I'm creating a list called mixed here. That's just a random name I have chosen. And I'm putting here some numbers 1000, 1100, and I'm putting a text 34, and I'm also putting 45.50. As we know that from our previous videos, these are the integer, this is integer, this is text type of data since it contains quotes, and this is the floating point number or float data. I'm also putting some names here: Harvard, MIT. I'm putting here San Francisco, and let's put one more list here: New York and Nashville, Washington, DC. I'm creating another list of, let's say, disease, COVID 19, fever, headache. I'm creating some, adding some more values here. True, true, false, 200. Even inside the nested list, I'm adding more and more values and different type of data within the list. I'm creating the one of the most complicated list here. Let's run this list for now. Let's run this line of code now. And if I would quickly print mixed and see the values, all of those are printed here. I want to also check type of mixed. Here you can see that it is the list type. Now, this is the power of list to store different data type: integer, string, float, boolean, another list, one more list, one more list, and inside those lists as well, we have stored different data. This is why list is really powerful. Let's explore another feature, another property of the list. After creating this list, now it is great time to get started and start extracting the value out of the list called mixed at the index level. Few things to remember here: Python indexing starts from zero. Indexing starts from zero. What that means is, as a human, we count the values. We count the value from 1 2, 3, 4, 5, up to whatever the counting we want to do. Now, however, Python indexing or counting begins from 0, 1, 2, 3, 4, 5, and so on. That is why when we want to extract the value from the list, we want to begin with index position 0, 1, 2, 3, 4, 5, 6, and so on. So this is going to be seventh index. This is one single value list within a list. This is going to be eighth value. This is going to be ninth value. So inside that ninth, we will also learn extracting how to specifically pull out Washington, D.C. So we will look at that as well. So again, this is zeroth index, 1, 2, 3, 4, 5, 6, 7. Here's 7, 8, and 9. Now, if I have to extract 45.5 from this list, I have to then say, first of all, type the name mixed and have a open square bracket, and within that insert the index position 0, 1, 2, and 3. So here the third index. Again, reminder that Python indexing starts from 0 and it counts forward after that. If I had to print that value here, print that value index position 3, then you can see that we have got 45.5 here. So likewise, if you have to extract the value Harvard, that is going to be the fourth index according to Python, put 4, and you got Harvard. How about extracting this entirety of the list? If you want to extract this one, then you have to go 5, 6, and 7. If you put 7 here, then it's going to be the entire list. For the list mixed, this list inside this list is the same as a single value. That is why we have got entire list when we called the index position 7. Same way, if you call index position 8, you will then get another list that we have defined with COVID-19, fever, and headache. This is how you can extract the individual value or the list inside the list, individual list inside the list. Then the next thing we want to learn, how about extracting the value from these many values? Let's say index position 0, index position 1, 2, 3, 4, 5, 6. So what do you have to do? Of course, you have to begin with 1. But when you say you want to extract the value until 6, one more Python rule you have to remember, that first value of the index calling is included and the last is excluded. So if you call 6 here, remembering that this is the sixth index value, if you try to extract that sixth value, let's see what happens here. So you have to put 1, the first value that you want to extract, and put a colon here. So colon in between, you can add a space here for readability, but you don't have to do that if you don't want to do that. And if you put 6 here, because this is the sixth index value, if you're recounting again, 1, 2, 3, 4, 5, 6, and that is technically the seventh. So 0, 1, 2, 3, 4, 5, 6. So if you put 6 there, then surprisingly you will not get San Francisco, but you will get until MIT. Why? Is because the last value that you call in the index as part of extracting the data, it will be excluded. Remember, every time you want to extract the value until a index position, then you have to call until +1 index. So that being said, you have to put 7 here to be able to extract the value until San Francisco. So here now, finally, you have got the value at the index position 1, that being said 0 and 1, that is included, and the value at the 7th position, 7th is excluded. That means the value until the index position 6 will be included. 0, 1, 2, 3, 4, 5, 6. So now finally we have got San Francisco. This is how you can extract the value of specific range. If you want to get the value, everything until the index position 8, then you don't have to necessarily call 0 here, because that will by default Python will use the first value in the list. If you run that, here you're getting the value from index position 0 on even if you did not call that value to be 0, and then you are including all of those until the index position 7, because the 8th index value is excluded. So first included, last excluded. Some of the rules that you need to remember in Python indexing. So we are getting 0, 1, 2, 3, 4, 5, 6, 7 here, 7th until the 7th index. This is how you can extract the values, individual values, range of values from a list. I want to also show you one more feature of the list, which is called negative indexing. Negative indexing is pretty popular. Imagine your list, this list being over 1,000, 10,000, or millions of values in a list. Whenever you work with a data from SQL table, from your Excel documents, CSV files, etc., each individual column values go up to millions of rows, if not billions, and maybe sometimes billions as well, sometimes thousands of lists. But now you do not know what is the last value in the list. In that case, how would you say mixed? And can you definitely say there are 10,456 rows in that specific list? It's really difficult to say that. So the list has a feature called negative indexing. Negative indexing will allow you to select the very last value in the list. So if you say mixed -1, it's going to give you the very last value in the list. For your comfort, let's add one more single value in the list, which is called train for now. I will rerun that list again. The last value is train value. You just added one value, and you're getting, when you call mixed -1, the negative indexing, you are getting the value train. This is how you can extract the last value in the list using negative indexing. Negative indexing works in such a way, so this is -1, the very last value, the second last value, third last value, fourth last value, and so on in the list. How about extracting the values from range of values from the last values of the list? For example, I want to say mixed here, and I want to extract the values, everything from -6th, so 6th last value up to everything. So when I say up to everything to the last, I don't have to specifically say -1, because that will ultimately exclude train here. So if I run that, the train is never included here, because we know that first included, last excluded. So -1 will be excluded. So everything you want the value is from -6th value up to the 6th last value up to the end. Then you would not say anything there, and that will give you the train, the last value in the list as well. You can define the range. For example, you want up to the third last value. So then what you will do is you will put the -2. If you put -3, that negative third index will be excluded. So if you run that, it will give you the values from -6. If I say -1, -2, -3, -4, -5, -6. So I want to include the value from MIT up to the -3. So -1, -2 is excluded. I want to include everything until here. Look at the value here until the headache. So COVID-19, fever, and headache. This is one small list inside the list. So that whole thing is included when I call this indexing. We have seen pretty complex list here so far with some examples. As you can see that this list contains the integers, the string, the floating point number, some booleans, some small list inside the list, etc. But not necessarily all the lists are of this complex. So lists are pretty simple as well. When you look at the data, most of the data columns that will be ultimately converted to the list, those will not have these variety of the data. Those will be as simple as, for example, I'm just creating another list, the numbers 10, 15, 17, 12, 17 or 16, and 27, 34, 12, and like that. And the values, these will be the very simple list. Or at some complexity, some lists contain the nested list. At worst, nested lists in the sense list inside another numbers, couple of numbers there. So this is another nested list inside the list. Mostly we don't, as part of the good quality data, we do not expect much of the nested list, or at least we do not expect different type of data inside a list as a good quality of the list. All I did was to help you understand what all the things we can do and how one single list can contain many different type of data. Another list, I can say names here, names of the cities: Boston, San Francisco, and New York, etc. And most of the list will contain the one specific information, not conflicting with many different information. So as part of the good quality data, you can expect the simpler list than what we have seen so far as part of our learning journey. Additional property of list that I want to review with you here is adoption of duplicate values in the list. So we have reviewed that list can handle duplicate values. We have the list names defined here. Let's print the list names, and we can see that it has values Boston, San Francisco, New York, Washington DC, Philadelphia, Boston again. So Boston was here, Boston is here, and also San Francisco is here, San Francisco is over here. That being said, list doesn't have any issues with printing duplicate values. Next, we will look at the list operations. That means what other things we can do in the list. We have predefined list names that contains the city names. In that city names, what we want to do in the beginning is we want to add a city name Houston at the end of the list. So to do that, what we can do is, first of all, call the list name and use the function called append and insert the value that you want to insert in the list. If you run that line of code and if you print the names list, you will see that Houston is added at the end of the list. Now you want to also add one more city dot append. You want to say El Paso. And if I run that, if I print the names list again, you have El Paso added at the end of the list. So append always adds the value at the end of the list. One thing you have to remember while adding the value at the end of the list using append function, it can only add one value at a time or a list of values, but that also should be just one single list. For now, you want to append names.append couple of cities: Seattle, San Jose, Los Angeles. If you run that, you will see that it has a nested list inside the list. It hasn't added the individual city, but it has added a single list of values as you have passed a small list of value. If you try to add more than one value, names.append, and I want to pass a couple of cities here, Nashville and Atlanta. If I run that, I will get error. List.append takes exactly one argument, 2 was given. So you cannot add multiple values at the end of the list as individual value. It has to be either one single value or one single nested list inside the list. We can additionally insert values in the list at the index level, inserting values in the list at the index level. So to do that, what we have to do is we have to use the function called insert. Right now, at the index position 0, 1, 2, we have New York. I want to insert a different city than New York at that index position. I want to insert Dallas there. So what I have to do is I have to say insert list name dot insert. I will give the index position 0, 1, and 2. So I want at index position 2, I want there to be Dallas. If I run that, if I print the names list again, you will see instead of New York earlier, now it is Dallas. That way you can insert the values or a single list of values at the index position. You can also remove the values from the list by calling remove function. I will call names list dot remove, and I want to pass the value, what value I want it to be removed. Let's call New York for now and run that and reprint the names list. Now the value New York at the index position 0, 1, 2, 3 has been removed, and we have Dallas and Washington DC. Dallas and Washington DC. There is no more New York. How about removing the value that is duplicate? For now, Boston we have in 2 places. I want to call the name of the list dot remove. I want to put Boston. So if I reprint the names list, then you can see that the very first value, the Boston, has been removed in this revised list after removing Boston. That means the remove function will remove the very first value in the list if it has same duplicate values in the list. Next versatile yet simple function I want to introduce here is the pop function. Pop function removes and returns the last element of the list or at the index position defined of the list. Let's print the names list here that we have been working so far. First of all, it returns or it removes the value or element from the original list and returns that list as a last, that is the last element of the list. So if I would use the pop function names.pop, I'll just run like that. See what happens here. Let's print now the names original list. Our last element of the list before running the pop function is Seattle, San Jose, Los Angeles, the last sub list inside the list, right? So nested list inside the list, that was our last element. Now pop function has removed that. Now the last element of our list after using the pop function is El Paso, which was earlier the second last. Now it is last because it has removed the last element from the list. Now we have also said returns the last element. When you run that, it removed from the original list, and also it returned the value from the list. What has been popped out, it has returned. And that's what the function does. First of all, it removes from the list and it returns as a result of pop function. By default, it always removes the value from the last part of the element, last part of the list. However, you can also alternatively define from which index position you want to remove the value, right? For example, here we're removing -3. So -1, -2, -3. So we want to pop out the San Francisco value from the list. If I would run that here, it returned the value. Print the list now. There is no San Francisco at the third last index. It's now Chicago. So it popped out, removed the value from the list, and it returned the value. This returned value you can also assign to a variable. For example, I want to say single city, and I want to use names.pop. I want to remove the value from index position 2. Here, now our new list was 0, 1, 2. I want to remove the Washington, D.C. from the original list, and I want to assign as a single city. If I print now single city, also I want to now print the names list. Look at the result. Here it has popped out the value from index position 2. It has assigned to single city. When we printed that single city, now Washington, D.C. has been popped out of the original list and assigned to single city. Now, if you see our original list, that the most updated list that we have after removing Washington, D.C. is without Washington, D.C. Dallas and Philadelphia. Dallas and Philadelphia. So Washington, D.C. has been popped out of the original list, and the new updated list, we have it over here. That was the quick introduction about one of the most powerful, simple, and versatile function in the list. You can also perform some mathematical operations within the list value. For example, you have a list with some numbers: 10, 8, 7, 8, 9, let's say 0, 9, 12, 45. This is a list. What I want to do is I want to get the summation of all the values in the list. What I can do is I can call sum of all the values. If you run that, it will sum all the numbers. You can likewise, in the same way, you can get the maximum of entire list. If you run that, 45 is the maximum value of the list. You can also get the minimum of the list. Minimum is 0, and you can see that minimum is 0 over here. You can get the minimum of the list. You can add two lists together. So here I have one list with Jackson, Perry, Carrie, John, and the second list I have with Harry, Son, and Peter. In that case, if I would run that, these three have been joined with the first list, and we have a final list with all the values included. You can assign that to be the final joined list. You can give the name, and if you run that, and if you print final joined, so you will see that all the values are joined together and you have a final list here. So list is really powerful and versatile. In the next videos, we have also introduced many dynamic capabilities of extracting values from the list, iterating values from the list using for loop and while loop, etc. So please stay tuned and watch those videos for more advanced topics, advanced capabilities using list in Python. Again, thank you for watching this video. Please subscribe to my YouTube channel, Data Speaks, for future videos, and please turn on that notification button so that you will get instantly notified when I upload important and knowledgeable videos in the future. Stay tuned, and I'll see you in the next video.